this is a momentous evening for many different reasons, but one of the reasons is that, well, most of you know that Mike gets into his office well before 7 o'clock most mornings. What that also means is that a Driscoll sighting after 4 p.m. in the afternoon is extremely rare. But this evening, not only do we have a Driscoll sighting, Mike has actually agreed to say a few words. So Mike, if you would come up to the podium.
My goal is to give the shortest speech on record, so pay attention. Yeah, I pulled together a few slides. I'm just going to show one. And I'm going to, well, you can just tell me. Yeah, see if we can pull that over. I made up what I originally called a Santa Claus list. I want to leave people feeling good. There's an amazing number of things that might happen which could leave nuclear in a very favorable position. And people know this already. And I'd like to invite people to send me more. And if we get this long enough, maybe we can get people to chip in and use nuclear. So let me just run down. Robust electric grid and cost-effective energy storage, hours, days, weeks, months. And if we had really cheap storage, obviously we can run nukes in a load-follow mode, in effect, by substituting storage. And so there are people here at MIT working on storage, and a lot of others elsewhere. So I feel pretty sure that's going to happen. I just can't promise when. The other thing, of course, everybody knows, a carbon tax. And yeah. And I'm trying to think a tax, of course, will never sell. And I'm trying to think, if you have a better word, and I've had people suggest levy, impost, duty, offset, penalty, compensator. You like compensator? Okay. If we do that, we're in great shape. We'll just drive everything else out of the market. So let's see if we can get that sold. Oh, and my friends who are doing computation, I asked them, well, how about a computer 10 times better than we have now? Oh, no, 10 times isn't enough. 100 to 1,000 times the speed and memory, best available current technology. And we heard some today where people are running a several hundred megawatt computer. Maybe that will do it. In which case, I hate to say this because I used to be an experimental reactor physicist, and they're now saying, oh no, we'll do it all with computers. So let's see. Fourth thing on my wish list is inexpensive high-temperature heat pumps and or high-temperature advanced reactors. And the Japanese are working on the heat pumps. The problem with light water reactors, we can't get hot enough to serve a whole bunch of other things, particularly synthetic fuel production. If we could do that, we would increase our market tremendously. So that I'm looking forward to, and we've got some ideas on high-temperature advanced reactors. And as I say, the Japanese are working on heat pumps. So let's see, what do I push here?
I got it. I just pushed it.
You got it? Okay. Yeah, this next one, I flinch a bit. Improved separation, which will help us in a lot of regards, except if our anti-proliferation people are here, they will keel over and say this would be a terrible thing to have happen if we could get dirt cheap separation. But I still think it could really be a boon in terms of our economics. And again, this is a mundane one, robust cladding and materials. Again, people working on, and we had somebody comment, is you really think you can get to 600 dPA, which you'll need something like that. I don't know if Pavel's here, maybe for the traveling wave reactor. I don't know, and we're fully confident that they will deliver. But if they could do that, we've got a tremendous, inexhaustible reactor concept with no reprocessing, and so that could happen. Cladding resistant to rapid high temperature corrosion by water. Again, we're working on that. Silicon carbide and other people are using duplex cladding, and we could improve the severe accident behavior and maybe, as I mentioned today, somewhat cheaper containment maybe if we're not going to have a hydrogen explosion, what have you. So again, there are people working on this, and gee, I think it might happen. Inexpensive processes for extraction of strategic materials, e.g. uranium from seawater. We already heard about that today. And the Japanese just announced that they now had a scheme for getting lithium out of seawater. And of course, a lot of people think that lithium batteries are going to make a huge difference. Well, automobiles, storage in the basement, which will allow us to load follow and a lot of other things. So onward, I think, getting near the end here. Well, inexpensive solid state materials, room temperature, superconductors, high efficiency thermoelectric converters, and I recently had the idea cheap in there because you need to make it economic. But I asked colleagues here at MIT, the smart physics types, is it possible to make some of these advances? And they can't tell you yes or no, so they're working on it. But maybe they'll deliver. There are certainly enough people working on improved materials, interfaces, what have you. Oh, and here, my favorite, I snuck in. If we could get rapid, large diameter, deep drilling capability in granite and salt or shale, we can go to deep borehole repositories much more cost effectively. And the criticism of the deep borehole, the Swedes looked at this, and ostensibly the reason they did not move in this direction when they made their final down selection was they could point to mines and say, here's a mine just like we want to put our fuel in, but we could not point, the Swedes could not point to a deep borehole which had all of the features that we needed. So you could find some that are large enough diameter, some are in the right kind of rock, et cetera, et cetera. But part of what Sandia will be doing is we'll go and have something you can point at and say, there it is. And there are, again, a large number of people working on advanced drilling technology, including here in our PFC. They have some kind of an electromagnetic device or something. That's one of the ways of doing it, and others have had others. So I can see something happening there, and maybe that will be a game changer. And then in terms of that, if people get comfortable with radiation, which is a long haul, maybe it will become less knee-jerk reaction to say, oh my God, nuclear, we don't want it. So that's really wishful thinking. Finally, getting near the end, realization of all, and I call it SMR hype, not intended to be critical, but especially for the FHR, which is the liquid salt cool system. And I see Charlie Forsberg there. he can go on ad infinitum at the advantages, like, what, 50% cheaper electricity or something. So really, and it's a believable case. It's a reactor which uses gas turbines instead of steam turbines. And the list of benefits is too long, so I put Nirvana in. And then finally, certainly rapid economic growth here, there, and everywhere, which will put increased demand for energy on the front burner and force us to do something other than burning lignite, as they do in Germany. So anyway, that's my list. Also, get going. What are you doing sitting around here? I want to get this realized in the next few Christmases, or what have you. And also, I want to leave everybody happy. So if you look, I guess, somewhere in some of the on the line or something, I was convinced to put in a list of doomsday scenarios, which if you're a masochist, you could go look at on your own, but I am not going to repeat that part of the story. No, don't show that. Yeah. I don't want people leaving here weeping and sobbing. So in any case, I think I've almost exhausted the time I had planned to spend on this, but it is very encouraging, I think, to think of all the things that can and probably will happen to really make nuclear even more attractive than it is already. And so I look forward to seeing it all come to pass. So thank you.